Back for the final lesson of our procedural animated caterpillar series. Last time we got started on adding limb animation. Now for the front legs, I think that minimal approach that we used is pretty good, and I think those are done. But the hind legs are really the star of the show here. If you remember all the way back when we first started working on this, we talked about this rear wheel drive that's motivating the whole animation here. It starts in the hind legs, so we want to make sure those are really sort of polished. So not just for the hind legs, for the whole caterpillar, I'll introduce today's theme, which is that I want to enhance the weight and vitality of this animation. So you could think of this as being kind of similar to last time's theme of creating like a grounded reality of the animation, but this time we want to focus more on adding like mass, force, and energy, right, with the vitality. We'll be trying to bring all of our elements to life. So we'll start by looking at the hind legs, but let's quickly review what we did with the front legs in the last lesson, because I think this concept will lead us right into how we want to sort of start enhancing the hind legs. So as we made our limb animation last time, we used this diagram to show that the body was kind of dragging the feet, they were sliding, and we wanted the feet to plant in either the previous or the next foothold instead, right? But let's make a diagram that shows how we actually fix this. And it involves the timing of the different elements of the animation. So in black, I'm just putting the overall cycle as it goes from 0 to 100%. Now the root level body movement starts partway through the cycle, and then it eases in and out as it goes from 0 to 100%. But we start the animation with this cascade from back to front, segment by segment. So each little segment has its own animation that plays from 0 to 100%. Now let's zoom in on this front segment and let's look at these timings closely. And let me just make sure these are exactly level, because we saw the disparity between these was key. The segment animation controls whether the foot's on the ground or off the ground. And so the foot is already planted here, but the body is still animating it forward. So that's what causes that slide. Now here, right, there's an even bigger disparity as we leave the previous foothold, and that also led us to see a larger slide there. So check out our last lesson if you want the full details on how we actually use this difference to fix the animation with this kind of more pragmatic approach. But we can actually use the same concept in order to enhance our hind leg animation as we get started with today's lesson. Okay, so here's the animation that we ended up with last time, and I'm just going to start scrubbing through this with some controls I added between lessons. Here's the code that handles those controls, and I'm actually going to be putting the full shader code that we end up with at the end of this lesson in the description. Okay, so let's start scrubbing through this animation, and here's the front leg. So we were just talking about these, and there's a nice anticipation now in these, right? As these bend back, they kind of build potential energy to release and lift the weight of the caterpillar to its next foothold. And we got this just as like a natural consequence of what we did last time to fix the animation. But if you compare this to the back of the body, these segments just start moving immediately, right? There's no sort of build or anticipation there, and it feels very floaty as a result. Now this is where the animation originates, where it starts moving, so it does need to start moving right away. But we also need to see it build the energy that's going to be required to move the whole caterpillar, like an even bigger version of what we have in front. So what if we add some kind of disparity in the timings of the way that we're driving the motion in back and see if we can use that to create anticipation? So let's scroll down to where we have our segment animation defined. We do have separate Y and Z offsets, right? Our segment animation progress is driving the Z directly, and this jump T is driving our Y position. Remember, that's kind of this half sine wave arc, and that tells us sort of from 0 to 1 how displaced we are in the Y axis, right? But we're just driving that with this same segment animation progress that we're using to drive our Z axis. So these both have the same exact timing on them, right? So what if we just use a different jump progress to drive the timing of the jump? So we could take our segment progress and then ease it in. And if we want to visualize what that looks like with this same kind of timing diagram here, so this would be the segment progress, and then here's our jump progress that we're easing in. So we'll move forward before we move up and try to almost recreate that slide out of the previous foothold in the front of the body. Okay, so if we use our jump progress here, we've got a little bit of a slide now. Let's take a little bit of a closer look. It's kind of hard to see. And so maybe we can increase this ease power. Okay, so that's definitely creating a nice slide there. And we want that in the body to create anticipation, but we can fix the foot and keep it planted by doing the same thing that we did last time, using the disparity of these animations that we just introduced, okay? So we can subtract out from our world space position if we're a foot, so we'll use the hind foot mask. We'll start with the whole move distance of the segment, and then that changes. So we have to add in the back influence t, and then we'll multiply in the difference in completion percentages, right, between these two animations to correct the foot's position, right? So that's going to be our segment progress minus the jump progress. And again, check out that last lesson if you want to go a lot more in depth into this. But this is looking pretty good. So the foot's now planted, but we have this nice kind of lean and anticipation of this segment cascade now. Now, if we play this, we will see, though, there's a problem with this. It's very rigid in motion, right? Especially in the front here. Now, we need this anticipation in the back of the caterpillar, but we don't really need it in the front. So we can do something to basically ensure that we're only changing the timing of this in the back. So where we did this sort of timing change, we can change this single value into like a jump ease variable. Okay, so we can interpolate from 1 in the front, so there'll be kind of no change, to this like snappier value in the back. Okay, so let's take a look at this. All right, so something broke. Let's take a look at this. Back influence T not defined. So we basically just need to move this declaration up, I think, so we can use it up here. So let's move that. Okay, so now we can see, I think the front is looking a lot better now. And so if you just want to compare what that looked like before, we can see that's very rigid looking, right? And then we can go back to what we have now. The front is much smoother now. But in the back, we still have this rigidity, right? We still see this crash down in the back. And that's a result of using this ease in on our jump progress, right? Ease in accelerates out. So that change in our timing is what's creating this crash down. Now, I do kind of like some aspects of this. It creates an accent, which is kind of nice, right? You can feel the weight and the force of the body crashing down to the ground. But I don't think it should come to a complete dead stop here, right? I almost want to see it like almost complete this sine wave pattern that we started, and move further down before it comes back up and kind of resets the position of the body, right? So we'll keep the jump animation as it is, but we'll add this follow-through animation to sort of cushion the blow and create like a secondary reaction animation to that kind of more dramatic primary action of the jump. All right, so for the timing of this, let's look at our nesting diagram where we showed sort of how all the different segment animations get spaced inside of the container of the whole cycle. And let's just add the follow-through timings to this diagram. And so we'll just take this ending point of each segment animation and just say the entire duration from that endpoint of the segment animation to the end of the cycle will be that particular segment's follow-through animation. So let's make a little section for our follow-through animation. And so here we can say that our follow-through start time will be our segment start time plus the segment duration. Okay, so that will give us like the end of the segment animation, and we'll use that in our follow-through progress. Now here we can make use of a helper function that I added between lessons, kind of as I added those controls to help us with the playback, and it's called nest to end. And basically we're just going to take some progress, nest inside of that with a start time, and then here's our duration. We'll just go all the way to the end, and we'll saturate or clamp from 0 to 1. So we'll just kind of save ourselves some keystrokes here with this helper. So we'll nest within the overall cycle, right, with this follow-through start time we just made. Okay, so now we have to figure out where we are inside that follow-through arc, right? So we can just take that same arc from the jump and use that now to create our follow-through T, and we can drive that with our follow-through progress. Okay, so then rather than adding this to our world space position, Y, for the follow-through, we'll subtract it. And then we'll just replace these variable names here. And for the amplitude here, we can actually base this on the jump amplitude and just reduce it by a certain multiplier, right? Like by a half, let's say. Okay, so let's see what this looks like. And okay, I mean, we are moving this down. I think we're moving it down too much, right? It's kind of going underground now, right? So we're already sticking the feet to the ground, but then the body, we're now moving below the feet. Okay, so where we're doing the grounding of the feet, let's just make sure that nothing is allowed to go below the ground. Okay, so we can just use the max of 0 and the world space position. Okay, now this does introduce a little annoying glitch, so let's take a closer look at this. So this is called z-fighting, and what's happening is that because of the fact that we're moving all these different vertices to the exact same kind of ground plane now, we're having all these triangles draw on top of each other, and the GPU can't kind of decide which triangle to show us. Okay, so let's take here where it says 0, let's turn that into a ground plane variable. Okay, so let's just replace those, and let's give each vertex its own special little ground plane. So what I'm thinking is we can just take the Y position of the vertex kind of before it's had any offsets applied to it. Okay, so we'll grab that, and then we can multiply that by some very small value so we get close to 0, but each vertex is not at the exact same position now. Okay, so I think we fixed the z-fighting, and now for our follow-through, the timing on it is way too slow. I think we want something a lot more snappy. All right, so here where we feed that progress into the sine wave, we can just ease that out. And let's use kind of a big value. We'll get kind of a really snappy motion out of this. And I think this looks pretty good in the back here. But in the front, we have a similar rigidity problem to what we had before when we created this sort of primary action. So we can do the same thing. We can just interpolate from 1 to 8 as we go front to back here. And let's see what this looks like. And I think this looks much better. I think maybe we can reduce the amplitude, right? We were going very far underground before, so we can just kind of cut that. So I think that looks pretty good. And the last thing I want to do with this follow through before we move on is I want to just add a little extra bounce to this, a little bit more elasticity. And I think we can just take this half sine wave arc that we're moving down and up with and sort of add a full cycle on top of that, right? So it will start and end at the same place as our existing follow through T, right? But we're going to add this full cycle to that. Okay, so this will be like another animation. We can call this the follow through bounce. And we can just copy our existing follow through and just start renaming. And this will be our bounce amplitude. And we can base that actually off of our follow through amplitude and reduce that further. All right, and then we'll just kind of replace everything. Okay, now here's the key. We want to use 3 pi as the period for this, right? We add 2 pi to what we had before. Okay, so this is kind of what we want. I think it's going way too fast. The timing is off. This easing, we're easing this out way too fast because we've got kind of more ground to cover here, right? Versus our original follow through. All right, so let's take that ease factor down to 2. And I think this looks much better. And let's just get a closer look at this new layer. Let's increase the amplitude by a lot here. And I think that's definitely too much, but I do like a little bit more maybe so we can kind of split the difference. And I think this looks pretty good. So let's compare this to what we had before we started adding this timing mismatch that caused the anticipation, right? We can see that's very floaty. And we don't even have to add a lot of this easing in order to see, right? There's a little bit extra weight, even with just a little bit of easing in. But I think there's a way we can improve this even further is what if we change how much of this timing drag we apply depending on where we are in the body. So if we take our hind foot mask, and let's just make sure we don't get a compilation error again, what if we get more drag on the timing at the bottom of the foot than we do where the leg attaches to the body? I think that looks really cool. And we could sort of increase this effect just so you can see what it does, right? This is sort of the extreme version. It's too much, but it looks kind of cool. It's very snappy, super elastic. But I think we've done a good job of enhancing the weight and vitality in our hind leg animation. All right, so we've added anticipation and follow through to our hind leg animation, so we can move on to the other elements now, right? Wrong. Not quite yet. Let's take that away. There's still one thing I want to add to these hind legs, or prolegs is what they're called anatomically, and the caterpillar uses these for gripping the surface that it's actually walking on. So as the caterpillar releases its foothold, its proleg will pinch in, and then in anticipation of it grabbing onto the next foothold, the shape flares out. So I want to add this kind of shape change element to our hind leg animation or proleg animation. So we can call it a flare. All right, and then we can say our flare T controls how much we're flaring in or out. and we can just use some debug value like sine of time, and that will go from -1 to 1, so we can flare in or out with this. Okay, now the actual displacement that this is going to add if it's flaring, it's going to be a 3-dimensional displacement. And we can just base this on the surface normal of the leg, right? So we can put that in here. Okay, so let's just add our displacement times our flare t to see what this looks like. Okay, so I mean, that looks kind of insane, but we just need to make sure this is only applying to the hind foot, right? So let's add the hind foot mask. And then let's also add an amplitude, right? This is flaring way too much, so let's do that. All right, and let's take a closer look at this hind foot. So there's still a problem here. And the reason for this is that, and let's just take this away so we can see it better. There's a back face on these. So this back face's surface normal points in a different direction. It points in. Now let's just take a closer look at where these back faces are created in the code. It's basically just taking the front faces and changing the winding order on them. But that does create this different surface normal. But I did kind of encode the fact that this is a back face into the parametric coordinates here on U. This is guaranteed to go negative. Now, U does loop, right? So I think this is actually mathematically equivalent. I mean, it's definitely a hack, but we can use this to create like a flare direction, let's say. And so we'll say whether our UV1 X, not Y, is less than 0, we'll flip this flare direction. Otherwise, we'll keep what we have already. All right, so now we're getting the right direction. This amplitude is too much though, right? It's kind of crossing over. So let's cut this down. And I think this looks pretty good. When we flare in, we're not going quite to a single point, but close, and then we're flaring out by the same amount. So now let's actually figure out how much we want to be flaring with timing. And we just, again, want to flare in as we release and then flare out as we kind of complete our jump cycle. Okay, so we could just interpolate from -1 to 1 over the course of this jump progress t. Okay, so if we kind of start scrubbing here, I think this is pretty good. And we could maybe add a little ease in out to this so we kind of stay more either fully pinched in or fully flared out. Okay, we can see what that looks like. And I think this looks pretty good. I think we have to look at it in motion. So let's start playing this. Now this does introduce an issue, which we can look at better, I think, if we turn on this smooth reset, which is another little control I added. So we don't just kind of warp back to the beginning of the cycle. And you can see, right, there's a pop now that we introduced. We just need to make sure that we reset this flare to neutral at the beginning and end of this animation. So we can multiply in jump progress, should start at 0, right? So we'll start at a neutral position. All right, and then we can just ease that out kind of aggressively so that we get back to 1 on our multiplier, which means we'll go back to that timing we had before, which I think worked pretty well. So yeah, here you can see, right, we start at neutral, but then we kind of quickly go to this pinched in position as we lift off the surface. But we still have the problem where it's not resetting back to the neutral position at the end. So we can just fix this with our follow through. We can kind of do the inverse, right? So as the follow through goes to 1, right, then this multiplier will go down to 0, so we'll go back to our neutral position at the end of the follow through. Okay, and so I think that we could just make this a little bit snappier. I think we could like ease out that follow through progress so we get to the neutral a little bit faster, and this creates a little bit of like an impact when we land with the feet, which is kind of cool. So I think this extra layer just adds a little bit of extra vitality, a little pep to the step of these hind legs, which I think are finally done now. And let's move on now to our horn animation. Okay, so I want these horns to be like a secondary motion element in this animation. And if you don't know what that means, basically just think about if you're shaking your head. The hair on your head will move in response to the head shaking because they're attached to the head, right? They don't move on their own. And so I want to see the horns kind of jiggle as they get jostled around by the body. And so let's work first on this jiggle animation, and then we'll mask it out later. So let's jiggle this in a circle on the XZ plane. So that means X will be a cosine of some input, and then Z will be the sine of that, right? Just think of our 3D modeling lesson. And so then for this input, we basically want to move in a circle depending on where we are in our animation cycle. And then we'll add some speed on top of that so we can add multiple repetitions of that circle. So let's just see what one circle looks like. I mean, it'll be way too slow, but we can just sort of get a baseline. So we can just add that into our world space position, right? If we're a horn, we'll multiply that in. Okay, so lots of problems here, but yes, it is way too slow. So let's increase the speed, first of all. Get something that looks more like a jiggle, right? We could go even up to 4 here. And I think that's still too slow, so we can double that again, go up to 8. And that's a little bit fast, maybe, so we can go down to 6. I think that should work. And let's also mask this out with our UV1 so that we only kind of get the tip of the horn here. And let's also add an amplitude to this. So we can say like 0.25, let's say. Okay, so we've got kind of a decent baseline here. Now let's improve this a little bit. Here, right, we see this kind of line down the body. I'd like to see the jiggle kind of move in different directions depending on which side of the body that it's on. Okay, so we can just flip the sign of this, kind of like what we did with the flare, but we'll use our world space position, X, to reverse the input. Okay, so I think that kind of adds some breakup to the motion. We don't get the exact same movement on every horn. Let's keep going with that. So as we go back to front, let's add some offsets here to our input. We can take like our segment order T, which is like that linear value segment by segment as we go back to front, 0 to 1. So we could add that in and take like a full cycle offset from back to front. Okay, let's add a lot more of an offset to that. So we can double that, and that's a little bit better. Let's do it again. And I think this gives us a pretty nice baseline jiggle animation that we can now start masking out, like with the timing of the jump. Okay, so if we use our jump T, which is telling us how far we are off the ground, we should only see the jiggle when we're off the ground. First, we have to make sure we actually multiply this in, right? Okay, so I think this looks pretty good in the back. Let's just focus on the back for now. So as the segment comes off the ground, right, we're seeing that sort of jiggle, but it just dies immediately when it gets back to the ground. So let's also add our jump progress, which will go from 0 to 1 and stay at 1. And then we just need to kind of transform this back to the 0 to 1 range. Okay, so this should give us more of like a sustain to our jiggle. And I think that is working as intended, but our jump progress will just stay at 1. So we need to reset this back to 0, right? If we turn on the smooth reset, we can see we need to reset our jiggle back to neutral. So we can multiply in 1 minus our cycle progress. So as we complete the cycle, we'll go back to 0 on our jiggle. And I think that also kind of takes care of those front horns moving so much too. So now I think maybe we could increase the amplitude a little bit, but this is a secondary motion. So right, I think we want to just use these horns to accentuate the segment animation, which I think it's working pretty well. So I think we can check off our horns, we're done with those, and move on to this final mystery element, which is that this caterpillar, as it's walking, is just looking straight ahead. It looks kind of robotic. And so I want to add some life, some vitality to this, right? By just having the caterpillar glancing around as it's walking. So it'll look side to side and up and down. Okay, so let's create like a look around animation section. And we'll start by saying just our look around mask will be, we only want this to affect the front of the body. So that would be 1 minus our body UV, okay? And we want this to be offset in both X and Y, right? So we can make this as another like 3-dimensional displacement. And then we'll just add that to our world space position. And we'll multiply our mask in. And then let's figure out what's actually going to go into this displacement. And we can start with something like sign of time so that we're not kind of tethered to the cycle repeating, right? We'll have some like variation from cycle to cycle here. And let's try to get a little bit of a better look at this. I think that we're applying this to too much of the body, right? We just want this to be in the very front. So let's apply some easing to our mask. So we use ease in, right? So this way, and we'll use a kind of a high ease power. So we're only getting the very front of this, right? Ease in will kind of make sure that we are at 0 most of the time. And let's also just make sure we don't add a new slide to these front feet because we are in the front of the body. So we can take 1 minus our front foot mask and add that to our look around mask. Okay, so for the Y displacement, let's not create a circle. let's kind of have these moving sort of offset from each other on different cycles. So we can just take that and add some speed multiplier so that they don't repeat at the same time. Okay, so let's take a look. And we're moving too much in the Y direction. So let's reduce the amplitude there. And I think we could reduce that even further, right? So it's just looking up and down slightly versus the X component. And I think this looks pretty good. And then the final piece of this look around animation is that I think it would be cool if it's only looking around when the body is not moving. So kind of between steps, it will take a glance here or there, but then while it's moving, it will kind of be looking where it's going. So we can almost do the same thing that we did for the jump, where we look at this half sine wave, but we can do the inverse so that between steps, it will be looking around. So we'll have 1 when the body's not moving and 0 when it is for our look around t. And we'll drive that with our, if I can find it here, here it is, our body move t. All right, so then we'll just kind of feed that into our half sine wave arc, right? And then we'll take 1 minus to get the inverse of that. Okay, so let's check this out. And so I think this looks pretty good. I mean, it's hard to tell whether it's working or not. So maybe we can ease this in, right? So we kind of bias this more towards just looking straight ahead at 0. I think this is pretty good. Let's just double check our timing logic here just to make sure we have this correct. So we can use some very large easing power just to make sure we're mostly looking straight ahead. And yeah, that looks very robotic. So let's just go back to what we had before, but I think this is all kind of working as we intended it. And I'm pretty happy with this look around element that we just added. And I think that's pretty much all we need to do with our caterpillar animation. So we can mark our look around element as complete, and we can also mark our whole weight and vitality pass complete. All right, so let's just play around with this a little bit and see how this reacts to different body configurations. So we can add a front leg, or we could change the number of segments. And if we do that, we're gonna have to also change the number of spots, right? So let's fix that. Okay, there's the spots. And maybe we could add some hind legs, right? But we've created this animation almost as a function of the body model. So as we change the body, like let's say we can add some more horns, and that's kind of cool with all those different secondary motion elements, right? And we can move those further back on the body. But anything we do to this model will be reflected in this animation. But I do like the setup we had with the model to begin with. So let's just go back to that. And let's also look at one of these controls I added to only reset the body after a certain number of cycles has completed, so we can kind of move with subsequent crawl cycles. And so now we're moving 4 before we reset. And let's turn on that smooth reset also. And we can kind of just check out the caterpillar as it does its thing. And so that concludes our caterpillar series. I think we've covered a lot of ground here. First, we modeled the body with our modular tools, and then we created an animation to kind of get the general idea of what the body would be doing. And then as we added the detail models, we found there were some complications to making sure that they worked with the animation, so we had to fix those. And then when we created the animation for the limbs, first we started with this kind of practical approach, and then we sort of further enhanced the sense of weight and vitality with our final animation. Okay, so I think we're finally ready to erase the whiteboard here. But we're not quite done with the topic of animation. We'll do a little bit more with this in our next lesson as we transition into simulation. So I'll see you in the next lesson.